We'll continue with some future value annuity problems here. Let's take a look at number one. It says, suppose you invested $1,000 per quarter over a 15-year period. Now, first of all, what makes this an annuity is those little two words right there, $1,000 per quarter. So that means you're putting in multiple payments of $1,000. So this has to be an annuity. Okay, so continuing on, it says if money earns an annual rate of 6.5% compounded quarterly, how much would be available at the end of the time period, and how much interest is earned? Okay, so just think about what you're doing. You're putting in $1,000 per quarter into an account that earns a rate of 6.5% compounded quarterly. So, as I said, you have quarterly payments, so you know it's an annuity. And your payments are designed to increase the balance, so you know at the end you should have a future value. So this is a future value annuity. So now we know we're going to use this formula here, future value equals payment times 1 plus I to the n minus 1 over I. Now, so let's see what we know. We know the future value is what we're looking for. We know the payment is $1,000, so put that in. Now I is the rate, which is 0.065 divided by 4. Since we're compounding quarterly, it would be 0.065 divided by 4 for I. So replace I with 0.065 over 4 in both places. And then N would be 60 because you're making these payments for 15 years. And if you're making 4 payments a year, that would be a total of 60 payments or 60 periods. And then we're going to subtract 1, so we have the minus 1 up there. Now, if you plug this into the calculator, like I've got it written right here, you shouldn't need to do multiple calculations. You can just put 1,000 in parentheses, 1 plus 0.065 divided by 4, close parentheses, raised to the 60, minus 1, close parentheses, divided by, parentheses, 0.065 divided by 4, close parentheses, then hit enter, and you should get the answer that I got, $100,336.68. Now, to find your interest, you just take the future value, in other words, what the account is worth, less what you invested. Now, you invested 60 payments of $1,000, so you only invested $60,000. So if you take the future value of the account minus the $60,000 you invested, then that's how much of the investment is actually interest. So that's how you find the interest there. Now let's look at a sinking fund. A sinking fund is when you know what future value you want. You want to know what payment will get it. So here, let's say you need $12,000 in 3 years. And you want to know how much you should invest per month. Now again, since I'm investing this per month, that tells me this is an annuity. And I want to have $12,000 when I'm done. So basically I know that these payments should increase the balance. Every time I put another payment in there, it should increase the balance. So since I'm making monthly payments, I know it's an annuity. And since the payments increase the balance, I know it's a future value annuity. And so I'm looking for payment. I want to know the payment, so I'm going to use the payment formula of the future value formula. Still the future value formula, but I'm just looking for payment. So now I have payment equals future value times I over 1 plus I to the n minus 1. Now, I know the future value that I want to have is $12,000, so I put that in here. And I know that I is the rate, 0.06, divided by the number of compounding periods per year, which is 12. So the rate is 0.06 over 12. I mean, the I is 0.06 over 12. So I have that in my numerator, and then in the denominator, I have the quantity 1 plus 0.06 over 12. And then it's raised to the 36th power because I'm only going to do this for 3 years. So if you make monthly payments for 3 years, that would be a total of 36 periods, 3 times 12. And then, of course, minus 1. And again, you can do this on your calculator, and you should get 305 0.006 for your answer. Now, actually, I could have used 0.005 here instead of 0.06 over 12, because that would be a terminating decimal. Okay, now if you wanted if you want the interest, we know the future value of this investment is $12,000, and you know you're only going to deposit 36 payments of 305.06. So if you take the difference of those two numbers, that gives you the interest is $1,017.84. So here's another problem. On your 21st birthday, you make monthly payments of $500 into an account that pays 8% compounded monthly, and you continue the payments until your 51st birthday, so you do it for 30 years. How much money will be in the account, and how much of it is interest? Well, again, it's monthly payments, so it's an annuity. The payments increase the balance, so therefore it's a future value. And so you just take the information you're given and you put it in your future value formula. The payment's $500, and then in the numerator you have 1 plus I. We know I is the rate, 0.08 divided by 12, M. And then we have a N, which is a total of, N is 360 because you're going to do this for 30 years monthly, so 30 times 12 is 360, and then minus 1, and then of course you also divide by I, 0.08 over 12. And so I got 745, 179, and 72 cents there. And if you want to know how much interest you earned, then the future value, take the future value and subtract how much you invested. And you invested 360 payments of $500, so take the difference of those two, and that will tell you how much interest you earned over there. So you can see you earned quite a bit of interest on that investment. Now, the next one says, all right, so we know I got this much, so what if I decide, okay, that's how much I'd have if I made investments of $500 each month. But what if I said I'd rather have $1 million after 30 years? Then I figure out what payment would get me there. Well, then this would be a sinking fund problem. So you could go to your sinking fund formula, plug in $1 million for your future value, and then, I is still 0.08 over 12, and then N is still 360. So you just do the sinking fund formula with future value of $1 million, and you'll see that it's going to be $670.98. So if you make a payment of $670.98 each month, your future value would be $1 million rather than the answer that we got. Okay, let's take a look at this next one. Suppose the parents of a child begin making quarterly payments of $1,000 into an account paying 7% compounded quarterly. Payments begin on the 10th birthday. How much will be in the child's be available on the child's 15th birthday? Okay, so really, again, this is just a future value problem, annuity. They're putting $1,000 in each quarter, so you put $1,000 in for your payment, and then your 1 plus I, your I would be 0.07 divided by 4, because it's 7% compounded quarterly, so 4 times a year. And you're going to have a total of 20 payments, because you're going to have 4 payments a year for 5 years, so it'd be 20 payments, then minus 1, and then divided by I, and you get $23,701.61. And then it also says do it for the 21st birthday, but all that changes, it just changes in, because instead of doing it for 5 years, now you'd be doing it for 11 years. So if you make the payments for 11 years, then this value would change to 44, because 11 times 4 would be 44. And you would obviously get more money, $65,453.15. So this video basically focused on your basic future value problems. In the next video, I'll solve some problems where you're looking for other variables.